Good morning, everybody, once again. The presentation is about the subsystem of the Hubert system, which was built by our team to export data from Hubert in a flexible way. Because I think that we have here a lot of people who do not work in Hubert-related technology and don't know what Hubert is, maybe even. I would like to make a quick start and tell you what Hubert is and what it does. Hubert is a content management system built in MediaPress by the team in Katowice. And its main goal is to be a front end for all our customers' product, and the platform that we can share with our customers, that we can deliver them as a environment of work. So basically, Hubert consists of two parts. There's the Hubert, which is content management system, and there is a Phobos, which is digital asset management. As you can see at the top of the screen, Hubert can ingest and can work on different types of data, or data from different data domains. So of course, first and foremost, it imports data from TVMan, because this is the main set of data our customers are working on. But it also imports sport metadata and hence sport metadata from sport metadata providers. Maybe the sport API tells you something. It also imports the data from the culture domain. Right now we are storing there the data about the cinema program in France, for example. It also can ingest the metadata of any other form of any other content, because this is the general content management system, so it is not limited to the one set of data, to the one data scheme. Last but not least, it also can include the assets that customers bring with them. So, for example, if we have a new customer and this new customer has an archive of texts or ratings or any other things, this data can be imported into Hubert and integrated with all other data that it's connected to. This is the common scenario, for example, when customers migrating his magazines, his paper magazines to Hubert, and has the library of texts connected to the movies or actors or whatever. This image is taken from the commercial presentations we are giving. So at the beginning of it, it's a very simplified image of the system. At the beginning of it, we have a layer of AI services which currently process the photos that goes to Phobos. Then there are two main blocks, which is Hubert and Phobos. On the left side, there are editors working on in the user interface, and on the right side there's a whole subsystem of Hubert which takes care about the print production, because all print products are now done in Hubert. And on the output, Hubert can produce the data which has been processed by the users, or it can export the ready to print pages for a print production. Today we'll be talking about this part. So this is the part called Oxana, and it is supposed to get all this data from different data domains and export it to the one format in a comfortable way. As I mentioned, Hubert has a flexible data scheme. That means that the structure of the data stored within it is not coded inside the code. It's configured in one of our user interfaces. So so basically, it means that each type of data, each structure of data can be introduced into Hubert without the need of coding. This is all done by our support team led by Mariusz Moszek. This configuration is done in one of the configuration panel. Maybe I'll switch to the live presentation for a moment to show it for you. Just a moment. Okay, as you can see, this is the panel our support is using to create the data schemes. You can see that, for example, this is a scheme called TV content, and contains the equivalent of the content from TV Man, and it has a lot of fields which correspond to the fields in TV Man, like for example title with all the properties. But it also can contain the fields which are added to the content. For example, fields which were requested by our customers. For example, there's a bunch of fields which were added by binding to this TV content. So it is really possible to mix the data from TV Man, data from the customer. As the Hubert is a cloud system, which means that the number of customers can work on our cloud instance of the system simultaneously. There is a need to build a system that will separate data from one customer to the other. That's why each of these fields and each of these data schemes can have the permissions granted or revoked for different customers. Okay, let's get back to the presentation. Okay, these data schemes I was mentioning previously can be linked together, so they create the kind of graph of interlinked entities in Hubert system. To make it easier for our customers to work on it, it is sometimes very important to be able to build a kind of simplified mapping from this complicated graph into just a set of fields that we would like to use in a particular context. That's why the very important part of the Hubert is called a mapper, which of course makes mapping. The mapping is the process of getting the data from the particular fields from particular parts of this data graph, plus there's some properties which are system properties, and produce the flat record out of it. So the mapper definition, because the mapping is also defined in the UI, mapper definition takes particular fields. Well, field 2 from content D, field 2 from content B in this case. It can also map the information from the rubrics. Rubrics are the selections of the records done by the user, by the customer within Hubert system. It can also contain information about the selected, about the photo selection in the context of the particular record, and can also refer to the photo metadata from Phobos. And on the output of mapper, it contains the flat record with just a key value store, where values are of the particular types, and a lot of components in a system works on this extract. Let's switch again to the little short presentation. Yep. The mapper looks like this. I've built a small mapper for today's presentation. It's called DevDay test, and this mapper contains 4 fields. This is title, and title is taken from the TV Man title. So this is mapped to the TV Man title. This is mapped to the TV Man subtitle. Because we are talking about the data graph, I also took the sport venue name in case of the sport programs. And this sport venue is taken from the sport API domain. Last but not least, I also took the title from the customer's archive. So the customer TV Media, one of the leading Austrian magazines, has its own archive of texts and titles in Hubert, and we are now referring to the TV Media title. So after this mapper is run, we will get just the four string fields, one with the title from TVMan, one with the subtitle from TVMan, one with the title from TV Media archive, if it is possible if it is available for this record. And if this record is a sport record, we will also get the information about the sport venue or sport stadium or arena where the event is played. As you can see on the right we have the selector that allows us to select the fields from different elements of this graph, which is available in Hubert. As you can see, there's a lot of these elements right now available in the mix. Let's get back to our presentation. Oh, sorry. Okay, so what is Oxana in this context? Because we have the data which is very flexible, which doesn't have the standard, the constant data scheme. It was crucial to build a subsystem that will be able to get the data from these different blocks linked together and export them in an easy way to the external customers for an export, for an online export, for any other stuff. So the principles of the Oxana framework are written here on this slide. First of all, we decided that there will be no code interface. Every aspect of this configuration will be done to the extent possible, of course, within the UI. You will have the possibility to flexibly select what you would like to export. As the Hubert is supposed to be integrated system, it will also integrate the images either selected or just attached to the records. The important principle is also that at the end of the Oxana processing, you are not getting the data in the customer format. This customer format translation takes place afterwards. So at the end of Oxana working, you are getting the standard JSON file, which encapsulates the data from these schemes which are inside Hubert. The data formatted in this standard JSON and containing data from different blocks can then be delivered to the multiple types of targets. I will be talking about this as well. And of course, we wanted to ensure that the most possible the most possible number of the standard scenarios are present in the Oxana out of the box. So how does it work? Basically, there are two types of Oxana exports. One type just gets the selected contents out of the Hubert contents and export them fully. So each field will be exported in this export. There's no selection here. We are just telling, for example, take the TV event, take the TV content, TV-based content, and export it wholly to the JSON file, and Oxana produces the JSON file with all this data here. But of course, this produces very huge JSON files at the output. So it is good to have a way to somehow fine-tune this output. And the easiest way to do it is to use this mapping technology I was mentioning before. So Oxana also works in the context of the mapper. You can have you can define the mapping and then give this mapping to Oxana, and it will create the standard JSON files, but only with these fields which are mapped using this mapping mechanism. Very important thing when you're exporting data incrementally is to be able to preserve the ordering of the exports as the changes in the data stream occurs. To handle this problem, we have also built our own queue management system, which is called Mona. And here is called event distribution bus because it's kind of the role it took. And Mona is a subsystem that is able to provide developers with the multiple event queues, which can be filled in with multiple producers per queue. So you can have several processes writing your information about the changes into the queue. And what's kind of distinguishing it from the other solutions available on the market, it is able to support a huge number of subscribers per queue, because it was meant to kind of distribute this update information among a huge number of the subscribers. And this multiplication does not cause the multiplication of the queue messages themselves. So we are not making a separate copy of the queue for each subscriber, as it is, as far as I remember, in Rabbit. We are just having one queue, and the subscribers have their own pointers to the queue, and they are able to get the and these pointers kind of preserve the context of their operation. Because of this, state of the subscriber is preserved in the Mona and queue, so you no longer have to store the last updated in the file or something. You are just registering with Mona with your subscriber name, and the Mona automatically knows where you finished. It's a possibility to define the multiple topics per queue, so you can distinguish between the messages of the updates of the different aspects of your data. If this is not enough, you can also add custom metadata to the queue items. And last but not least, the Mona was designed with a lot of security in mind. By security, I mean to limit the possibility of losing the event information, because its main purpose was to be used as update notification mechanisms. That's why there are several levels of security which can be applied while writing the data to Mona, while writing the information to Mona, to prevent you for losing the something in the middle. Okay, so Mona is also used in the Oxana as in the scenarios when we would like to make it easy for the customer to get the incremental updates. So basically, this file delivery Basically the Mona is a component that services that stores the whole history of the updates that Oxana has exported. I mentioned before that that Oxana supports delivering the data to the different targets. By different targets, I mean that Oxana is able to produce just JSON files in the local file storage somewhere on a disk, on a shared disk, or it can also deliver this JSON files to the Azure file storage. And so this is the simplest mechanism. Mona is just, well, exporting JSONs. This export takes place in kind of batches. This batches can each of these batches is done in a separate folder. These folders can be automatically zipped. There's a lot of mechanism to make it easier for transport this exported files, for example, to the customer's FTP. But this is generally the simplest and also the kind of the most traditional way of exporting data out of the system. Of course, the MonaQ is also available. So if the customer is able to, he can attach to the queue and be informed when the new files get exported and what is the ordering of the files to be imported on its site. Oxana is also able to deliver photos, and by photos I mean the photo selections. So every photo that is described in the photo selected, that is selected in the photo selection. I am talking here about the selection, the Hubert photo selections, which also supports TVMan to photo selections. But not only, because they also support the selections, for example, made for print production or for data domains not supported by TVMan. So to be able to deliver a customer also the photos that he selected and cropped and processed, Oxana is able to apply some additional processing to the photos from Phobos and export the ready for production files also either to the local file storage or to Azure file storage. By processing, I mean that the photo gets cropped in a way which is described in the photo selection and scaled to the proper way. But we also the Oxana is also able to perform pruning of the headers of the IPTC EXIF headers to shrink the size and to anonymize the photo if needed. Oxana also does EXIF normalization. In an EXIF header, there is a parameter that can rotate the photo. The photo itself is not rotated, but the EXIF header parameter can perform this rotation when, of course, this rotation is available and supported in the end product. To make it easier for customers, Oxana can also normalize this. So if there is a rotation defined in the EXIF, Oxana just rotates it and deletes this EXIF flag from the header. And last but not least, Oxana is also able to perform the ICC profile, the color profile normalization. So this is also to make the life easier for our customers, because not all devices support the ICC color profiles. So when the photo in Phobos contains such an information and it is normalized, it can be displayed in the wrong colors on the output device. But this file delivery is just one part of the story. Because Oxana is also able to deliver the JSONs directly to the number of databases. And the number of databases is now 3. Of course, next types of databases can be added by request of our customers. So Oxana is able to deliver these JSONs directly to the Elasticsearch index, directly to Postgres database, or directly to the Azure Cosmos database, which we made. It is not used in production. We just made it for making a proof of concept of this Azure Cosmos database. This makes our lives a little bit easier because we are getting rid of the files in this context. So there's no need to provide the file storage. There's no need to clean up the file storage. You probably all know that the file handling can be a little bit cumbersome in some cases. In this scenario, the data goes directly to the database and is, for example, and is directly searchable as well. But there's another scenario that Oxana supports. Is a delivery via API. So if the customer wants to have the incremental notifications about the changes in its data domain, he can just rely on MonaQ messages and receive the information from Mona about which records has been changed and call our API to get the JSON files transmit this JSON files via API to its system. So this is something that does not demand any database, any staging, or any file storage. It's just the customer calling the API. But this API delivery has also another variant, which I think is right now a little bit preferred by us because it is the most secure and performant variant of the API delivery. And this is the API delivery with staging. By staging, I mean the Elasticsearch index. So the idea here is that MonaQ is providing us with the notification informations, and Oxana is storing all the modified records in the Elasticsearch index. But we are not allowing a customer to directly call API from our living system, from our production system. We are providing a customer with the oxana-proxy. Oxana-proxy is a simple API made to be very, very simple and easy to use for the customer, which in the background gets data from the MonaQ and is also able to get the data from the Elasticsearch correspondingly. So the customer does not see any of this complexity. He is just provided with a very simple API to get the information about the changes and get this change records. This can also be made even more complex when the customer wants to have data in the other format, in the customer's format. Because as I mentioned at the beginning, Oxana produces data in the standard format, in a standard encapsulation format, because the contents of the format changes because of this flexible data scheme. But if there's a need for customer to get the data, to transform this data into XML of specific format or JSON with specific naming of fields, it's possible, of course, to apply another block. This time, this will be the custom block, but it will be very simple to write. That will get on the input the data from in Oxana standard format and just transform this format to the customer format. So this is how we handle the specific customers formats. Let's get back to this oxana-proxy. Oxana-proxy contains generally 4 very simple methods. First, there is a method get changes. and there's a parameter in where you can define how many changes you would like to, how many next changes you would like to see. But generally, at the beginning, it just returns 10 next record which has been changed, which are waiting in the Mona queue. Of course, we know that life isn't so simple, and sometimes there is a need to reply some changes, to re-export some changes. And that's why there is a possibility, and this relies on one of the features of MonaQueue, that you can kind of rewind your pointer in the queue to the given timestamp. So there is another version of this get changes, which also changes the pointer to the given timestamp. You can say, okay, give changes, get me changes, but starting from the Friday, because then something went wrong and we have to repeat it. Once the data has been delivered, once the information about the changes has been retrieved, the customer is able to use the get records method that will just return him the JSONs for the IDs the customer retrieved from the queue. And when customer is ready with this record and he's sure that he processed all of them, to somehow close this transaction, there is the acknowledge method, which is also very simple. You do not need to give any parameters to it. It just acknowledges to the MonaQueue that these 10 or 100 changes has been processed and the pointer in the queue can advance. So basically the communication gets like this. Customer gets changes. It can return either IDs of the records or the full records to not create too much network traffic, and customer acknowledges this, and then this whole process repeats. So it's just a get changes, process changes, acknowledge, get changes, process changes, acknowledge. This simple API also has the method. This is the fresh method, so it's not included in the presentation. I just wanted to mention it. And this method allows customer also to get access to the Phobos, to the original photos from Phobos. Of course, this communication via oxana-proxy is authenticated and guarded by Aloha system. So the customer is sending, along with the request, customer is sending his own API, so we know what parts of the data customer has access to. It also refers to the photos, so the customer that doesn't have the rights to the particular photo will not get it back, but the data, but the method is in the API. Okay, I will switch now back to a little live presentation to show you how it works in practice. Okay, so this was the mapper, and let's return to the to Oxana. Oxana is also, as I mentioned, Oxana is also configured using the user interface. So I built two export out of Oxana just to show you what it can do practically. The first one, the DevDay text, is a export which is based on a mapper. So as you can see here, there is a user interface. I describe that the root of this graph that we will be exporting is TV event. I also chose the type of the product, the type of the export to product. There are two general types of the Oxana export which can be used. One of them is content and one of them is product. The content exports are used to export generally the everything that is in a database in the context of one of one content scheme of the content graph. without referring to the Hubert products. So maybe I'll just tell you quickly what the Hubert products are. Each of our customers can establish a number of products in Hubert. Product can be the product is generally the configuration of something that the customer does to get the output. Very generic definition. The product is, for example, the print magazine, like in this case, like in TV media. The product can be, in case of our French customer, the one that we love the most, the Telerama. The product can also be the interface configured for a customer to maintain the customer's archive, like in this case. The product can be an interface configured to produce the data, like for example, Sport API product. Oh, come on. Yeah, so these are this is sport data. And well, there are also products which are supposed to take care about the photo selection. You know, a lot of workflows that are done within Hubert. All of them are encompassed in a product. So let's return to this TV media, because this will be the product used as a base for Oxana export. And this is the product which this is the TV magazine, so it has the information from TV Man about different channels, with additional informations filled in by the customer plurimedia. They have the access to the photos, possibility to write their own texts, and so on and so on. And they also have something which is called rubrics. Rubrics are the selection of the records, because, well, for example, they have the page with the tip of the day when they select the programs from the different data domains. So these red dots are the rubrics. Each product also has the columns. These are the columns of the products on the left side. So when the export is of type product, it has the columns on the left side here to choose, and I chose these columns with these TV channels to be exported. So it is just a number of them, just to be able to show it quickly. Then I am able to decide what I would like to export for these columns. So I decided that I would like to export the information which is contained in the mapper, because this one is a mapper export, and this comes down to those 4 fields. So I will be exporting basically for each record on these channels. I will be exporting the information about the title, subtitle, sport venue from Sport API if it is available, and TV media title from TV media archive if it is available. So I'm mixing the data from different domains. As you can see, there's a lot of additional properties you can set here, but I will not tell you about it right now. I can also use filters. This is the mechanism of Hubert, and in Hubert, everybody can define their own filters with their own conditions to be able just to, well, filter out the records. I can define how the photo attachments, what will be the format of the photo attachments to export, and what will be the format of the photo selections to export. And of course, last but not least, I have the possibility to define the output. What will be outputted from this export? As you can see here, I have a number of the options to choose. I will choose the Elasticsearch because this will be the easiest way to show it the results of this export. When I chose the Elasticsearch, system also gives me the possibility to choose which Elasticsearch engine will be used, because it supports multiple Elasticsearch engines. And I just have to tell how the index in Elasticsearch will be named. So right now, when I want to start this export, I will show you the index in Elasticsearch is DevDay test. So I will show you that this one is empty right now. It doesn't exist even. And I will start this record and ask the record to export to re-export the data to this index. And Oxana starts to run. As you can see here in the properties, there are also some properties connected with the interval of these exports. You can define how frequently Oxana will get the changes and export it, how many threads of exporting will be used, and other technical parameters. Right now, Oxana started to export. The records are processing. Let's see if we have already something. Yes, we have. So these are the results. These are the records that are results of Oxana running. The record exported is here. So you can see that there's some metadata about the last modification in an epoch format, and here starts the information about a TV event, which is a root schema here, and it contains the subtitle and it contains the title, because there's no sport venue or TV media archive here. But to show you that it also exports the information about the sport venue, I will make a search of the records that contains this information. And for example, for this record, it also exported the title from TVMan and the name of the arena from Sport API. In case of TV Media Archive, of course, it's for some records where the TV Media title is available, it exported title from TVMan and title from the TV Media Archive. Here's a nice example, because this record also contains the selection of the photo. So you can see that this selection is done here. And the details about what photo has been chosen to this selection, what are the parameters of the cut, what are the parameters of the selected media file in this context. So this was the export based on the mapper, but of course you can also set up the export which is the content type in this scenario. So we will not be exporting the data in a context of the particular product in Hubert. We will export just the content of type TV event with all fields here. We have to define the areas to inform Oxana what are the boundaries of the export in case of areas, and then we can select the number of schemas to be exported. Just to show you how does it look in the full form. Yeah, so you can see that I selected just a few of them, and this is the whole tree of contents that is currently available in a Hubert system. So these are all the possibilities, all fragments of the data that are available coming from the root from the TV event schema. But for now, I just chose the event content, TV-based content, and the plurimedia archive, the old plurimedia archive, and our beloved customer Telerama archive to export. For each of these schemas in this type of export, we can define if you want to export fields, all fields or just selected fields, when these fields are supposed to be exported and so on. So there's a number of additional options. Of course, the filters are also available here. Because this one is the content type, it is not connected with one particular product, but you can still include the rubrics or photo selections from the number of products here on the list. So I chose here that I would like to get the information from TV media, and I would like to information about these rubrics and these selections. In this scenario, you can also choose multi-language variant of the export. So you can export not only data in one language, but in all languages or in selected languages. And here you can also choose the channels that you would like to export, attachments properties, photo selections properties, and the output properties as well. So I will show you that this one is empty. This is DevDays 2. No, it's not. So I will delete this. Yeah, now it's empty. I will start the export. And the export starts processing. And we will be seeing the records almost immediately. As you can see, the format is a little bit more robust here because it exports all the fields from the TV event schema. And what's more, it exports it in also it exports the fields that are language invariant in the fields section, but it also exports the fields that are multi-language in these fields for a different languages. So well, the record is much bigger here. Okay, I am almost at the end of my time. So I think that I will leave some time for questions if you have any. If you have any question, just raise your hand metaphorically. Okay, so everything is clear. So I will end my presentation here and pass this stage in 6 minutes to Paweł, which will tell you about debugging of .NET Core applications within the Kubernetes environment. Thank you very much for listening. I will now stop the recording.